This video is sponsored by Amazon. I recently flew to Seattle to visit Amazon's audio labs in Bellevue for what was pitched to me as a straightforward tour of their new Echo Dot Max and Echo Studio smart speakers. But what I actually got was engineers arguing about millimeters of woofer clearance, magnetizing speaker drivers with a weaponized capacitor bank, and standing in an anechoic chamber while a synthetic voice recited Harvard sentences over simulated pub noise. I watched domain experts from acoustics, thermal, RF, and industrial design explain their fight for what they needed, none of them fully getting what they wanted, but while somehow collaborating to ship a product that's surprisingly good. Particularly when it comes to the brand new Alexa home theater experience, you rarely get to see this kind of process unfold in public, and that is the story that I want to share. Pete Kiriakou runs Echo hardware at Amazon, so he's the guy that has to balance what customers want with what's physically possible. And I wanted to start here because these devices are not just Alexa delivery mechanisms anymore. They've clearly designed this hardware to be the platform for current and future LLM technologies, and that shows up in some unexpected places.
These were built from the ground up for Alexa Plus, and by that it just goes down so many different avenues. We'll start with the fundamentals. Alexa has to be great at sound. It's one of the biggest use cases, and sound is both an output, great acoustics, and an input, the microphones. And you asked about the microphones. Custom silicon on these devices, the Echo Dot Max has a processor in it, the AZ3, and the other three devices have AZ3 Pro. Now these are unique silicon that are built first party from Amazon. Our devices team was able to design them with Alexa in mind. So not only for great acoustic output, but the great pickup. And so we have edge AI processing that helps with noise reduction and wake word detection, which makes them great listeners. And that's some of the digital work that we did to make the listening of these devices great.
And this is by no means a solved problem. Putting speakers and microphones right next to each other inside of a device this small is basically asking for acoustic feedback and echo cancellation nightmares. I mean, the fact they've got entire anechoic chambers dedicated to testing something as simple as wake word detection when you say Alexa shows how much effort goes into the things that we kind of just expect to work.
When you get domain experts that come in, whether they're an RF engineer, reliability engineer, acoustic, display, everyone wants to bring their best game. And those things don't always compose themselves to where everyone gets what they need in a design. But when these were designed, we really focus on the acoustics and bringing in that integrated system to life.
That's a fascinating thing to hear from a VP, that when domain experts fight for what they need, someone has to lose a little bit somewhere. The trick is making sure that those compromises serve the right priorities. And here, sound quality won. But with all of that custom silicon inside, I was curious what else these speakers are doing when not playing music.
And then we have some incredible technology we call it Omnisense. And what that's doing is it's using a variety of sensors on the devices, Wi-Fi radar, Wi-Fi CSI, ultrasonic, in addition to some of the thermal sensors that it has on there, accelerometer. It is doing things like not only measuring the temperature in a room, so you can use the smart home hub that's built into all these devices to just check on temperature in rooms and make sure it's calibrated, maybe set a routine to lower or raise the temperature depending on your settings. But also present detection, so wanting to know when you walk into a room and turn on the lights. These are some of the routines, and they're really simple to set with Alexa Plus. All natural language, all conversational. You can ask your Alexa to turn on a device when someone walks in the room. You can ask it to turn off a device when someone exits a room, turn on lights and things like that.
So that's the what. Now we need to talk about the how, because the drivers themselves need to be designed and validated before they ever enter anything that resembles an Echo. Amazon designs their drivers in-house, but until recently, they've had to rely on suppliers to actually build their prototypes. That's starting to change.
This is a magnetizing coil, and which we need to magnetize the magnets that are in the loudspeaker drivers. This is a huge capacitor bank.
Wow.
Okay, so you charge up the capacitors, and we're talking a huge amount of capacitance, basically to create and store charge, such that when it's time to fire off the magnetizer, basically you dump all that charge as current through this coil. You have to generate, like, we're talking like at least 3 Tesla of magnetic field intensity, and that creates a toroidal magnetic field at a very high intensity right here. And so that's, you put your loudspeaker driver magnets inside here, fire the thing off, and they magnetize. This is not the kind of magnetizing coil you would see in a production environment. It's very much aimed at a prototyping environment. In a production environment where you're building speakers at a every 6
rapid
seconds,
rate, yeah.
they're water cooled.
Once they have a magnetized driver, well, they need to validate it, and that's where Frank comes in. Frank demonstrated a microphone array, 18 tiny mics arranged into an arc that measures a bare driver's performance. They mount the driver inside of a 3D printed fixture, and then they seal it in a small chamber to isolate the backwave. And then they just run a bunch of frequency sweeps, a sine wave starting high and sweeping low and then reversing. The software spits out polar response plots showing how loud the driver is at different angles, different frequency response curves, and electrical impedance measurements. It's how they characterize a driver before it ever goes into a real product. But testing a bare driver only tells you so much. Once it's inside an actual speaker enclosure, the game changes completely. On one hand, you need to know how the device sounds to users, and on the other hand, you need to know how users sound to it. For the first part, there's Bill's robot.
The anechoic chamber, I think you've seen a couple, you'll see a larger one in a little bit. You can measure an on-axis frequency response and get a point of understanding of how the speaker will sound. With this equipment, near field scanner, scanner implying that it measures frequency response in all directions. 3D ionosphere surrounding the device. This is the measurement microphone. It tells us things like how wide is the beam, right? Our devices particular don't just sit in front and center on a desktop.
They're designed to be omnidirectional, right? And listen to from every angle, and yeah.
So there are frequency implications, where the tweeter sits, where the woofer is, baffling effects. All of these have impact in 3D space. So just a flavor of what it sounds like. I wish it was more exciting, but
Okay, so that handles outbound audio, but these are Alexa devices. They need to hear you too, and for that, well, they use the large anechoic chamber. And when I walked in, it was not the dead silence that these rooms are famous for. It was loud. Pub noise was blasting from speakers all around while a mouth-simulated speaker recited what I later learned are called Harvard sentences, basically phonetically balanced phrases used for voice testing at an Echo Show device. The idea being that it can help improve on-device voice processing in noisy environments.
4 hours of steady work faced us. The birch canoe slid on the smooth plain.
Very soothing voice, I like
It's
it.
a very soothing voice.
It feels like we're in a pub.
And we try and make sure we're engineering for challenging situations. Not that we're trying to engineer for your pub necessarily, but
I've seen them in pubs,
exactly, right? Your home can be just like this. In the kitchen, fans running,
Kids screaming.
kids screaming.
Yeah.
Turn off that blasted music. Whatever it is, you want to be able to pick up what's going on, what you're actually interested in.
So that's how a speaker is validated. But a speaker is not a product. The real challenge starts when you try to shove all of those drivers into a sphere that customers won't complain is too big. Richard cracked one open to show me just how tight these manufacturing margins are.
We fought for every last little cubic millimeter of space in here to basically get as much volume inside for the woofer as possible. So if you look at these very closely,
They're encased.
they're self-sealed,
That's cool.
right? And that required a significant amount of engineering because we needed them to go down to the crossover frequency that we were targeting given the size of the device and the performance objectives that we have for the device. You can see where the woofer is venting out the bottom, right? And that was also a fun engineering challenge. You're squeezing the air down, right? And then the air's coming out the side. It's omnidirectional at these low frequencies, so that's great. But there's always the risk of the air velocity being much higher when it's exiting out of a narrow channel. It's exiting through fabric. So even the ribs, the fabric, the tensioning on the fabric, everything was engineered.
None of this would be necessary if they just made the thing bigger, but customers, well, they had opinions about that.
The spherical shape was chosen because it actually was, we had our previous gen with the Echo and Echo Dot, and customers liked that shape the best. They had, tried other shapes, and they're like, no, the sphere is what they like best. And so we went to our ID team, and they're like, what's the biggest sphere we could have? before customers are like, that's too big. Like, can we do a basketball? They're like, no.
It's got to be small.
It's got to be small. So they kind of gave us these limits.
So you've got industrial design demanding a small sphere, audio engineers fighting for air volume, and then, well, there's thermals.
It's one thing to get everything to play in here, but then also these things are generating tons of heat, including that
Sure, the
AZ
SSE and the amps. And
yeah. So lots of thermal problems to deal with, and the power that we had to use, because the smaller the enclosure, the more power we have to pump into it to get the speaker to move.
There's actually 3 magnets. You can only see 2 of them. There's a third one inside. One of the ways that we manage getting the amount of output that we're looking for and managing the thermal loading and the power is to try and make these things as efficient as possible, which is why all the magnets are in here.
Yeah.
Right, to make it respond naturally to the electrical input, not require as much to do the job.
Every department pulling in a different direction, which, as it turns out, is exactly how it's supposed to work.
So do not get me wrong, there is always tension.
Sure.
The tension is healthy.
Sure.
Right? It helps you make sure you're making the right compromises.
Yeah.
If you approach that in the spirit of teamwork, you get fantastic
Results.
fantastic results. You deliver something you didn't think was going to be possible.
Yeah, ID wanted small, thermal doesn't want too much heat, we want big sound. All these things are working against each other, but that's where great engineering happens to come up with new solutions to these problems.
So that's how they build a speaker. But now that I'm back here at the studio, I wanted to see how all of these pieces actually come together. And while I can't really show you the music listening experience via YouTube, I can show you something more visual. Alexa Home Theater. This new feature just released, and it allows you to use Echo.Max speakers, or in my case, Echo Studio speakers, to create virtual wireless surround sound. And the setup process is surprisingly straightforward. On your Fire TV, you navigate to Settings, Display and Sounds, and select Alexa Home Theater, and then create. The Fire TV will walk you through setting up your Echo devices with a video that I'm gonna skip. Maybe. The system will automatically find my nearby Echo devices, and you can add up to 5 Echoes plus a subwoofer. Then you push save and continue. You don't tell it which speaker is front left or rear right. You just select them, hit save, and the system runs calibration tones through each one. I'm supposed to be quiet right now, so it's not going to work very well. But each speaker hears every tone from other speakers surrounding it, and from that data, the system builds a spatial map of your room. If you're using Echo Studios, they even provide height channels via the upward firing drivers on top. And rather than routing everything through your potentially congested Wi-Fi network, the Fire TV creates a Wi-Fi direct mesh to each speaker, dedicated low latency connections for synchronized audio. And it's done. Okay, I don't have a center channel, but other than that, this is a pretty standard home theater setup. I've got 2 Echo Studios up front, 2 in the rear, and well, I've got my show, Reacher, on Amazon Prime Video. How does it sound? I don't know. Let's figure it out. I do like that volume control displays on all of the speakers at the same time. That's nice. Well, the music sounds good. For there being no subwoofer, there's a surprising amount of bass coming out of these speakers. I'll tell you what, the bass is boomy enough in these to slightly rattle the door on my entertainment console. Need some masking tape.
I'm not a ventriloquist. Get off my lap.
Wow. Dialogue sounds really, really good. It sounds like there is a speaker in the center. That virtualized center channel is really impressive. And that's great because so many soundbars in particular, dialogue sucks.
Move faster than that.
Sir, if you step over here, I can process you.
It's really
I'm not
good.
asking, sir. I'm telling. But don't worry, I won't kick your ass unless you make me.
Oh, she's funny.
This is the last of it.
Okay, next transfer, I want half of the boxes. I don't know how 4 people accumulate all of this.
The rear channels are good. What you'll find in a lot of cheaper surround sound systems is that you get blasted with audio from the rear. That's not natural. You shouldn't really hear the rear channels unless you're really focusing on them. And that's the case here. It's very subtle, very well done. It's great. You can hear stuff coming from the rear channels. You can hear it bouncing off the ceiling. It really is shockingly good. And these are just 4 little balls that I've placed around my room. But this, again, is a fairly traditional setup. 2 speakers up front, 2 speakers in the rear. But it doesn't have to be that way.
With that setup, we allow customers to put them wherever they want. So if you've got space up front, great. If you've got a side table, put one over there. If you've got a bookshelf, put it on the bookshelf. We don't care because we will detect where each one is, and then we will dynamically render the audio to play back in the proper, with a proper 514 rendering. No matter where they're at.
Well, we're going to put that to the test by doing a truly unhinged setup that nobody with a right mind would ever do, or nobody that knows anything about audio. You see, the system takes the incoming audio stream, say Dolby Vision, and re-renders it as 514. And then it's re-rendered again at the individual speaker as 211, given where the speaker is placed inside of the 3D environment. So it's almost like each speaker is its own surround sound system, because in a way, it kind of is. And well, we can place them in truly stupid spots, like, let's literally put it on the floor. So we've got 1 speaker on the floor right next to me. We've got 1 in the center, 1 way up here on the left, super high, and then 1 way very far in the back. There's no way this is going to sound good.
Well, this is a different fight sequence, but perfect.
What the hell are you 2 doing down here? Come on, let's go before the warden sees. Let's go, let's go.
Okay, the center channel is doing a lot of the heavy lifting, but I gotta say, it sounds fine. Like, it's not as good as it was before, but totally acceptable and way better than you would get, not just from the internal speakers on the TV, but from, honestly, most kind of like similarly priced soundbar setups. It's totally fine.
That's where they got it.
It's really interesting because you do get some of that stereo phasing before, but you have a really prominent center channel because it's right in the middle. It knows it's in the middle, so dialogue is coming straight out of that middle speaker, whereas before, it was coming out of both speakers simultaneously. So it is clearly adapting to the environment. And well, I think the only suggestion that I could give is that maybe when you're doing something truly unhinged, it goes, hey, maybe just put them in a little more normal of a position. But again, it's totally watchable. It honestly sounds like it's coming from like this right here, about where a door would be. That technology is so cool. Look, I expected a PR tour, but what I got instead was a team of engineers who clearly love the problem solving that goes into making something like this work. Something that, when designed well, is supposed to disappear, to just blend into your home and work. A bit ironic, given the years of methodical and painstaking work from some of the most talented engineers in the industry, but I suppose that's kind of the point. All I can say is that the fruits of those labors, at least by me, are now noticed and appreciated. Thanks to Amazon for sponsoring this video, and thanks to you for watching. As always, stay snazzy.